This is the second of our multiple comparison, our contrast video. And just a quick reminder, you can pause and play along with your textbook. For this one, we're going to start by looking at some of the planned orthogonal contrasts. Those are the contrasts where if we cross multiply any two of the contrasts and sum them up, they should equal 0. On page 62 in your text and also in the activity handout we used, we figured out some of the planned orthogonal contrasts when we have 4 groups. So I'm going to go along with that example on page 62. I'm going to conduct this analysis under compare means and one-way ANOVA. It's another way of getting the same one-way ANOVA, but you can only do one-way analysis of variance with this method. Later on, we're going to see factorial models where we're only going to use the other way in SPSS. So, level of attractiveness is our grouping comparison. We put that into factor, and number of statistics class is still our dependent measure. I'm going to take and go to contrast. There's several options. For now, I'm going to just leave everything as default. And I'm going to go under coefficients, and I'm going to put in those contrasts that we've had before, where we take half, or 0.5, and 0.5, and compare it to minus 0.5 and minus 0.5. Well, what does that mean? Well, for this individual contrast, that means we're going to take half of group 1 and half of group 2 and compare it to half of group 3 and half of group 4. I simply typed in the comparison side for the coefficient and added that. If I wanted to remove something, I could select remove and I could retype something. For now, I'm not going to do that. You're welcome to play along at home and try that. I'm going to click next. Now I'm going to put in the second contrast. First one didn't disappear. If I go back to previous, it's still there. I click next, and I'll put in a +1, a -1, a 0, and a 0. If you need to, take a moment and hit pause and look at your textbook and think about what we're comparing. If you paused, then hopefully you thought through and said, well, I'm comparing group 1, positive, to group 2, negative, the entire mean, and I'm zeroing out groups 3 and groups 4. For my final one, I want something that's going to be orthogonal to both of those. And our last comparison is going to be 0, 0, a +1, and a -1. And just quickly, we could see if we wanted to, you can go back and pause and do all the comparisons, but if we look at this comparison, 1 and -1 with 2 zeros, and 0, 0, 1, -1, if we cross multiply those, we're going to end up with zeros. And the sum of 4 zeros is going to be 0. It is an orthogonal contrast. So I will click continue, and I'm just going to go ahead and click OK. We can see that we have our analysis of variance, again, is 6.8, significant. We have our contrast effects code. So this is actually the code that we just put in case we make a mistake. And if you're putting these in by hand, you can easily make a mistake. And we get what those contrasts are. We can see assuming variances to be equal, just like kind of in our old t-test model, we had assuming variance is equal and assuming variance is not equal. Well, here, if the variances are assumed to be equal, we see what the t-value is and its associated significance level. We can see that there's a significant difference in contrast 1, a significant difference in contrast 2, and no significant difference in contrast 3. On page 63 of your text, you will be able to see these 3 contrasts and how they were calculated by hand. But now you know how to do it in SPSS. A side note, for those of you that get interested in syntax in SPSS, I'm a big SAS guy for syntax myself, for programming, but I like to capture and use some SPSS syntax often if I'm going to reuse an analysis. And up here what I'm highlighting is the actual syntax code SPSS used. For those that want to get involved with syntax, my recommendation is to start with some of these type of syntax, copy, paste, and go on from there. If you have more questions, come to me during office hours, and we could go over how you could work a little bit in SPSS syntax. I won't do every type of contrast, but I just want to show you that under Analyze, and if we go back to the one-way ANOVA and go back to the contrast, I'm going to go ahead and reset this, put these back in. So anytime you want to start over, I reset. I'll put back in level of attractiveness and number of statistical class into our model. Go into contrast, and sometimes I just want something very simple. I just want to compare group 1 to group 3. Maybe that's everything I want to look at right now. If that's true, I could put in group 1 and group 3 as 1-0 coding as effects code, as contrast codes, and I can just compare that as my only analysis here. This is a simple effects. We'll see how we can do every combination in a moment. If I click OK, when I run my analysis, I still get my overall omnibus f-test. I see what contrast code I put in, and I can see that I have ran a contrast test for just this difference between groups 1, attractive, and 3, moderately attractive. So this will lead us to our very first post hoc analysis, or one of the ones that is very useful when doing analysis of variance, and it's going to be our Tukey honestly significant difference test. I'm going to go, and although I could do this through compare means, I'm going to go back to the general linear model, which is what we're going to be using most of the semester. Under univariate, I am going to go to post hoc. I'm going to take all of these are post hoc analyses in SPSS that are relatively easy to perform. They're the defaults for the GUI interface for this dialog box. I'm going to take grouping variable that I care about, which is our levels of attractiveness, put it under post hoc tests. I'm going to select Tukey. And if you kind of go and play along at home and check your multiple comparison procedures on page 77 for our flow chart, we can see, well, we're going to use Tukey's test when we believe that there are equal variances, there are equal ends. I'm going to go check to see the differences between Tukey. So instead of just having one comparison, I have all of these comparisons. One of the things that you have to make sure of is that we care. You must have rejected the analysis of variance test here, where f is 6.8 and it is significant. That must be the case ahead of time before doing your post hoc comparisons. Otherwise, you need to stop. So I'll go ahead and do the Tukey's test. Go ahead and click continue. If you are back and with your textbook, you can also sort of look on page 68 where they start to talk about Tukey's test for the honestly significant difference test. This is a very useful when we have those equal ends. This is probably the most popular. When we have equal variances and equal ends, is probably one of the most popular tests that uses a standardized range test. You can check that out from either our class notes or what we did, or your textbook. I will point out one of the differences that is apparent in SPSS, the way it's calculated in the denominator after I run this test. So the idea here is now that we have it set up, we want to look at all of those pairwise contrasts. I'm going to go ahead and select OK. And we end up with multiple comparisons. These are post hoc comparisons. So I tested the hypothesis ahead of time that there was a significant difference somewhere on the one-way analysis of variance. Now I'm using Tukey's test, which controls using family-wise error. We're going to and modifies it with a standardized range test. That we're going to see where those significant differences lie. And here we can see we have blocks unattractive compared to the other three, slightly attractive compared to the other three, moderately attractive, and very attractive, each compared to the other three. There are redundant tests here. And if you go and look, you will see the redundancy. You will see that when I compare 1 to 2 here, unattractive to slightly attractive, we get the same and opposite values if we looked at slightly attractive to unattractive. And we have every possible comparison. So Tukey's test gives us those sets of comparisons. We would only pull out, obviously, those that were important. Those that were significant are the ones we'd be looking for, and also non-redundant. So when we look at, for example, the first little block here of unattractive, we see that there's a significant difference between attractive and attractive and moderately attractive and very attractive. And then we skip down, we see, well, moderately attractive and unattractive, well, we've already looked at that. Very attractive versus unattractive, we go back up and we see that's just equal and opposite to what we saw before. One of the things I wanted to point out here is that the denominator of this actually calculates in SPSS. That denominator is actually the harmonic mean, which is a slight adjustment than what's done in your textbook. It's fine, and it's accounted for in the significance test. So the number of statistics labs attended, we also see the homogeneous sets. This is kind of interesting. This is sort of the opposite in some ways of looking at separations. This kind of sees whether or not we have groups that kind of hang together. And for the number of statistics labs, we're looking at unattractive and slightly attractive as one subtest, and then all the other three are put into another to see whether or not there's differences or not. I'll continue on in this example with some other post hocs and comparisons in our third video. For now, just go ahead and practice the Tukey test and some of our comparison procedures, and check out the next video.